Hello, everyone. I am Javier Rico,
Hi, I'm Shaoqing Zhang.
and we're going to talk about anti-personal mines in Colombia, adding value via machine learning. So our findings, given select violence indicators, such as the number of murders, rates of civilian contact with armed groups, rates of recruitment of children and teenagers as child soldiers, and the number of demining programs, our model is able to forecast with an R-squared of 0.85 the number of landmines explosion in the municipalities that historically rank highest in landmines detonations. Based on past data on landmines detonations, our model successfully predicts 4 of 7 the possibility of a landmine detonating in a given Colombian department. Our historic context. Colombia has suffered an internal armed conflict for more than 60 years, which began as a bipartisan political war and switched to a war about control of the territory and coca drugs production. The need about the control of the territory introduced anti-personnel mines into the war. These bomb devices are installed beneath the ground, so they explode and harm the person whenever someone comes and steps over them. Usually, the person loses his or her arm, and in some cases, arm or leg, and in some cases, the person dies. Today, there are 4 major players in the armed conflict in Colombia. They are right and left-wing armed groups, where both sides are involved in drugs production, the government, and the civil population. The armed groups that work as guerrillas and paramilitary forces have created a forced internal displacement, which is related to landmines, and have also left abandoned field lands. In 2016, the Colombian government reached a peace agreement with a major armed group in Colombia, the FARC. The slowdown of the war decreased the number of landmines explosions, and the number of landmines reduced in about 7 times within the 5 years. Since 2018, the number of landmines explosions stopped decreasing. In 2018, the Colombian democracy elected a new president who doesn't support in full the peace agreements with the FARC. This could influence the progress shift in the violence measures and eventually reverse the progress made so far. The goals and policy value of the machine learning process, of the machine learning model. We want to forecast a number of landmines explosions in the next years, and we also want to classify geographic regions in Colombia that are likely to have landmines explosions in the upcoming years. Because there was a change in a trend between 2013 and 2018, we want to see if violence triggers can help to predict the possibility of having an explosion or not. The model is intended to help to determine if some additional policy measures can be implemented to reduce the likeliness of landmines explosions in some regions. By forecasting and classifying the possibility to have landmines explosions, we want to help policy decision makers and security agencies in Colombia. The interested stakeholders include the demining plan of the national government and the United Nations, the department governments interested in rehabilitating agricultural areas to be productive again, and the plan for returning the land to displaced people. The description of the data. First, we have 2 data sets. The first one is landmines, which includes geographic location and exact date of landmines detonations since 1990. And the second one is violence data set. This has yearly measures levels of violence triggers of every municipality. A municipality is the smallest geographic division in Colombia, comparable to counties in the US. At the beginning, we will start evaluating the forecast with the landmines explosions dataset. Then we will join the violence dataset. Depending on the performance of the models, we will use different aggregated geographical regions and different violence triggers that affect the number of landmines explosions. We can see a pattern of sustained number of anti-personnel landmines explosions since 1990 to 2000. Then from 2002 to 2016, the slope increases and it starts going down again by that year, which is the same moment when the Colombian government signed the peace agreement with the armed group, the FARC. The largest number of explosions were got in 2013, reaching 350 cases in a year. From this number, we can see that on average, there was about 1 explosion every day in the peak year. Since 2013, the number of landmines explosions has decreased. Targeting our analysis. Because of the way we approached the machine learning model, in order to obtain meaningful results, we based our analysis in those departments where we have historically the largest number of landmines detonations. The departments are equivalent to a state level in the US. Within each department, we have municipalities, which are equivalent to countries in the US, to counties, I'm sorry. The departments with the largest number of detonations are Antioquia, Meta, Caquetá, Arauca, and Nariño.
And here we're going to explain how we use machine learning model to help us solve the problems. And generally, we have two big steps, which are to do data preparation and to use our scikit-learn pipeline to implement machine learning models. And we're going to explain them in details in the following slides. The first step of the data preparation is to fill time gap. What does it mean is that since our model is time series based, we need to ensure that for each unique key, the time periods are full and continuous. Let's say, for example, here, if we have a municipality of 5201, and we only have 3 years of this municipality, and let's say that we totally have 6 years from 2010 to 2015 in our whole data set. So what are we going to do is that we need to fill the time gap of these 3 years for this municipality. So by doing this, the total years in this municipality will be full and continuous. And next, we need to shift our label 1 time period back, which means that we need to predict the number of explosions in the next time period, whatever is next month or next year. Let's say in this example, we need to predict the number of explosions in 2015 when we are at 2014. So we have the features of 2014 and we shift the number of explosions 1 time period back to here. So this becomes the Y label of the observance of 2014. So yeah. And next, I'm going to explain how we use the scikit-learn pipeline to implement machine learning model. And firstly, we create a customized sliding window transformer. Again, this is for time series model. What we do is that we want to know not only the number of explosions in this year, but also in the previous years. Let's say, for example, if we want to know the number of explosions in the last year, let's say if we are at the time point of 2014 and the number of explosions here is 0. And what about the number of explosions in the last year, which is here in 2013? So we just shift this 0 1 time period forward to here. So at the time point of 2014, we also have the numbers in 2013, and similar as the rows above. And one thing is that for the first year, there will be no data here. So we can just remove the first year, which is to replace it with 0. So here we just replace it with 0. So, and we can get the lag 1 feature of the number of explosions here. So we can generate several features and control the sliding window size. And next, we have several steps of feature engineering, and they can easily be done by scikit-learn. We just put them together into column transformer, and it helps us to do the whole things. Generally, they can like drop features to one-hot encoding for categorical features and standard scaling for numeric features. And here are the training and grid search tasks we have done. Basically, we do classification with logistic regression and regression model with linear regression as our baseline model, and also we improve the performance by gradient boosting regressor. And we also tuned several hyperparameters, which you can see are listed here. And after then, we do cross-validation. And since our model is time series model again, and the way that time series model do cross-validation is like, for example, if we select the year in 2013 to be the validation set, and all the training, all the data set before that year should be the training data set, which are from 2010 to 2012. And again, if we select 2014 as the validation data set, and the year from 2010 to 2013 will be the training data set. And next, we're going to show what we get from the models. If we do classification and we implement logistic regression on 3 levels, which are grouped by municipality and year month, also by municipality and year months, but this time we only analyzes those municipalities in the top 5 occurrence departments. And we also have one group by department and by year month. And you can see these are the record rates from validation and test data set, and they are improving in steps. And here is other metrics that you can see based on our department year months level model. And in the left, you can see that 4 out of 7 municipalities with detonations are found in July 2021. And yeah, you can see that totally there are 7 ones in Y2, and we predict 4 of them. And for our regression model, we use R² as our metrics to do the model. And we first try linear regression and got this R², and we improved the performance by gradient boosting model to be 0.48 for validation set. And you can see that the value for test data set is high above, which is 0.85. The reason is that we run the values into integers and to make them more accurate. And here is what we get for the model. We find that these are the top 10 municipalities with detonations in 2018. And you can see that we properly predict them. And yeah, here. And we also find top 10 important features, which are basically the number of explosions in the current year and in the last year. And since we combine the violence data set with the landmines data set, we also have like several features like number of murders, the indicators of children that forced to incorporate with army, and also the drug production. So these are the features that correlated with the number of explosions in the next year, which are, I think they are perfectly make sense. And I think that's all up for our presentation, and hope you will enjoy it. Thank you.
Thank you.